Hello everyone, in this lecture we will learn selection sort algorithm. Selection sort algorithm is comparison based algorithm and its time complexity is n square, which is quadratic time. And like bubble sort and insertion sort algorithm, in each passes only one element gets sorted. If we have n elements, there will be n minus 1 passes. Now let's analyze our algorithm. Below I will write an array, and this array is not sorted, and we have 6 elements, and these are the index numbers. At first we are going to do our first pass. For first pass, like bubble sort algorithm, we will rotate this array 90 degrees. Also, this time we need their index numbers. In selection sort algorithm, we will select a position. Now the variable I at the left shows the zeroth index. And we have to find the smallest element on this array for this position. We need to find the smallest element in the array for this position. In order to find the smallest element in the array, we need 2 pointers, and A and B will be our pointers. And at first they will show the zeroth index. And now we will move pointer B to the next index, and B now will point index 1. After we bring B to index 1, we compare 18 with 16, because A shows the zeroth index which contains 18, and B now shows the first index which contains 16. And because 16 is smaller than 18, we move A to the position of B. And now they all shows the same index. Now we move B to the next index. B will show the index 2, and again we will compare with 13 with 16. A shows the first index which contains 16, and B contains 13, and because 13 is smaller than 16, we again move A to the position of B. A shows the index 2. Now we move B to the next index. Now B shows the third index which contains 12, and because 12 is smaller than 13, we again move A to the position of B. Now again we move B to the next index, and B now shows the fourth index which contains 15. Now B shows the fourth index which contains 15, and this time 15 is larger than the value of A, which is 12. And this time we do not move A to the position of B. This time we only move B to the next index. Now B points to the last index, 5. Also, again this time 14 is larger than 12, so we did not move A to the position of B. But now if we move B to the next index, B now points an invalid index number, and we stop the procedure. Now we found that the smallest element, which is 12, is pointed by A. We found the smallest element in the array, and until now we didn't make any swap operations, and this time we swap with A with I, which means we will swap 12 and 18, and now our array becomes like this. And we sorted our first element, which is 12, the smallest element in the array. And now we move to our second pass, and this time we will use our new array which contains 12, 16, 13, 18, 15 and 14, and this time I will point to second element, and A and B our pointers will point the same element in the array. And we move B to the next index. B now points 13, and 13 is smaller than 16. So we move A to the position of B. And we move B to the next index position. And now B points 18. And this time 18 is larger than 12, so we do not move A. We move B to the next position. Now B shows 15. And again 15 is larger than 12, that we do not move A to the position of B. We only move B to the next position. B now shows 14, and again 14 is larger than 12. We do not move A to the position of B. Also we move B to the next position, which B becomes invalid, and we stop our search. And now A shows the second smallest element in the array, and we swap the value of A with I, and our array becomes like this. 13 and 16 will be swapped. And we have two sorted numbers, 12 and 13. Now we can move our third pass. And our array will be 12, 16, 18, 15 and 14. This array. And now I will point the third index. I will point 16, and A and B will point the same index. And now we move B to the next index. B points 18, and 18 is larger than 16, so we do not move A to the position of B. We only move B to the next position, which is 15. And now 15 is smaller than 16, so we move A to the position of B. And we move B to the next position, and now B points the last index, which contains 14. And this time also 14 is smaller than 15, so we move A to the position of B. Now A points 14, which is the third smallest element in the array. Also we move B to the next index, which B becomes invalid, and we stop our search. And this time we swap the value of A, which contains 14, with 16. And now our array 12, 13, 16 will be swapped with 16, and 16 will be swapped by 14, 18, 15 and 16. And we have three sorted elements. And this time we will move our fourth pass. The logic is the same, we only repeat the same process. And now I will point 18, and also A and B will point the same index, and we move B to the next index. B now points the 0, 1, 2, 3, 4, fourth index, which contains 15, and 15 is smaller than 18, so we move A to the position of B. And we move B to the next position. And now B shows the last index, which contains 16, and 16 is larger than 15, so we do not move A to the position of B. And we move B to the next position, which becomes which now contains the invalid index, and at the end of the fourth pass, we swap the value of 15 with 18. And this time we have 4 sorted elements. Now let's move our fifth pass. And now I will point 18, A and B will point to the same index, and we will move B to the next index, which contains 16, and 16 is smaller than 18, so we move A to the position of B. And now A points the last smallest element in the array, and we move B to the next index, which B becomes invalid, and this time we swap the value of A with I. 18 will be swapped with 16, 16 comes here, and 18 comes here, so we sorted all of our elements in the array. As a result, we can say that in selection sort algorithm, in the first pass, we made 5 comparisons and 1 swap. In the first pass, we made 5 comparisons. At first, A and B was showing the same index variable, 0 index. We move B to the next index, and we compare 16 with 18, and we made 1, 2, 3, 4, 5 comparisons. In the second pass, we made 1, 2, 3, 4 comparisons. At the third, 3, at the fourth, 2, and at the fifth pass, we only made 1 comparisons. As a result, we can say that in the second pass, we made 4 comparisons, and also we made 1 swap operation. Third pass, 3 comparisons, 1 swap. Fourth pass, 2 comparisons, 1 swap. And fifth pass, 1 comparisons and 1 swap. And the number of comparisons that we made for this example can be written as 1, 2, 3, 4, and 5. We made these comparisons for 6 elements. So if we generalize this formula, if we assume that we have n elements in our array, we would make 1, 2, 3 plus up to n minus 1. Because for 6 elements, we came to 5, and for n elements, we have to come n minus 1. So, which results n minus 1 multiplied with n divided by 2, which equals n squared minus n divided by 2. And we can say that order n squared. And if we observe the number of swaps in our selection sort algorithm, selection sort is very efficient. In each passes, we find the smallest element, and then we find larger elements in other passes. For bubble sort, in each passes, we find the largest element in the array, but for selection sort algorithm, in each passes, we find the smallest element in the array. Now we can write our codes for selection sort algorithm. So we made 5 passes for 6 elements. So our for loop will represent our passes. I will start from 0, I smaller than n minus 1. N will represent the number of our elements in the array. For 6 elements, we made 5 passes. For n elements, we have to make n minus 1 passes, I plus plus. Also, we need another for loop for comparisons. We said that we have 2 pointers. We need 2 pointers, A and B. B equals to A and A equals to I. For initialization, they all the same index, and B is less than n B plus plus. And we will compare the values of D of B with D of A. If it's smaller, then we need to move A to the position of B. And after these comparisons, it means that we found our smallest element. Then we need to swap values. We need to swap with d of I with d of A. End of the first for loop. Yes, the algorithm is very simple. Now we can use Xcode to implement our code and see the results. At first, I will include IOStream and namespace std, and for this time selection sort function will not return any value, so the return type will be void, and the parameters are the same as bubble sort and insertion sort. It will take an array, also the size of the array. So we need a for loop to represent our passes, and each passes we need to make some comparisons, and we need to declare B and A, and we need to compare d of B with d of A. If it is smaller, then we need to move A to the position of B. At the end of this for loop, we need to swap the values of d of I and d of A. Also, we need to implement a swap function above selection sort function. You know the logic of swap function. Temp takes the value of A, and A takes the value of B, and at last B takes the value of temp, which contains the value of A. And we need to define our main function, and we need to create an array of size 10. And now we can call our selection sort function. Let's call this M, and M contains the number of elements in our array. At last, we can use a for loop to print the values of our array D in sorted order. Let's run our program and see the results. And our new array became 5, 9, 11, 23, 21, 33, 34, 45, 54, and 67. And our selection sort function sorted our array. Now let's make an analyze to see that if selection sort is adaptive or stable. So to understand its adaptive property of selection sort algorithm, we can use this array as an example. At first, let's assume that I, A, and B points the smallest element in the array, and this array actually is sorted in descending order. And at first, what we need to do is B will point 9, and we will compare 7 with 9, and because 9 is larger than 7, we do not move A, we only move B to the next index, and B points to 13, and we compare 13 with 7, and 7 is smaller than 13, so we do not move A to the position of B. And with this idea, we move A to the last index, and after last index, we move B to the next index, which B becomes invalid, and at last pointer A shows the 0th index, which contains 7, and I points to 0th index, which contains the same element, which is 7. But we swap these values, so 7 will be swapped by itself. For adaptive property, we can say that it is not adaptive. Because in order to say that selection sort is adaptive for sorted arrays, the time for sorting the array should be less than for mixed arrays. But in our example, we have a sorted array, and the time that we need to sort this array is the same. So we can say that selection sort algorithm is not adaptive. For stable feature, it is a student challenge for you. Is selection sort algorithm is stable or not? Okay, this is the end of our video. I hope you liked the video. Next time I will be telling quicksort algorithm. See you next time.